A single artificial intelligence data center can consume as much electricity as an entire city. Not to power factories, not to run transportation systems, not to support millions of homes, but to process information. And as artificial intelligence expands across the modern world, some technology companies are now building infrastructure so power-intensive that entire electrical grids are beginning to strain under the demand. Because the AI revolution is no longer simply a software story. It is becoming an electricity story, an infrastructure story, an industrial expansion happening quietly behind the internet, while most people still imagine artificial intelligence as something lightweight and invisible floating somewhere inside the cloud. You open a chatbot, generate an image, ask an AI assistant a question, and within seconds an answer appears on your screen as though it materialized out of thin air. The experience feels instant, effortless, almost weightless. But underneath that illusion is one of the largest physical infrastructure expansions of the 21st century. Because artificial intelligence does not simply require software. It requires physical computation happening continuously inside giant industrial facilities filled with specialized hardware consuming enormous amounts of electricity every second of every day. And the scale is becoming staggering. Modern AI systems operate inside hyperscale data centers containing tens of thousands of advanced processors running simultaneously around the clock. Inside these facilities are endless metallic corridors lined with blinking servers stacked across giant industrial halls beneath harsh white lighting and massive cooling systems that never stop operating. Cold air circulates continuously through giant ventilation systems, while industrial chillers remove extraordinary amounts of heat generated by constantly operating hardware. Outside, giant substations feed electricity into these campuses every second of every day, while backup generators stand nearby in case parts of the grid fail unexpectedly. At night, many of these facilities glow across the landscape like industrial cities hidden behind fences, floodlights, and security checkpoints. And increasingly, they are growing larger, because unlike traditional internet infrastructure, artificial intelligence workloads are extraordinarily power-hungry. Training advanced AI models can require huge clusters of GPUs operating simultaneously for weeks or even months at a time. Every generated image consumes electricity. Every AI response consumes electricity. Every recommendation algorithm consumes electricity. Every voice assistant query consumes electricity. Each interaction, moving invisibly through the internet, is actually triggering physical infrastructure spread across giant industrial systems, hidden far away from the people using them. And as AI systems become larger, more advanced, and more capable, the amount of electricity required continues increasing alongside them, which is why technology companies are now racing to construct increasingly massive data center campuses across the United States and around the world. Some already span millions of square feet. Others are still under construction, expanding into giant industrial zones filled with cooling towers, transformers, substations, generators, utility corridors, and electrical infrastructure operating continuously around the clock. From the outside, many no longer resemble technology campuses at all. They resemble power facilities. Because in many ways, that is exactly what they are becoming, and the scale of electricity involved is difficult for most people to visualize. Some hyperscale AI campuses already consume hundreds of megawatts of electricity continuously. Certain future facilities are projected to require gigawatt-scale energy demand. That is city-level electricity consumption, not for manufacturing centers employing thousands of workers, not for transportation systems, not for residential districts, but for computation, for running artificial intelligence systems people interact with through simple phone apps and websites. Which means invisible digital activity is now reshaping physical energy infrastructure at extraordinary scale. And utility companies across the world are beginning to feel the pressure. Because modern electrical grids were never originally designed for sudden explosions in AI-driven computational demand. Much of today's grid infrastructure was built decades ago around relatively predictable growth patterns involving homes, factories, office buildings, and gradual population increases. Historically, electricity demand rose slowly over time. But AI changes that equation completely. Because giant data center campuses can appear rapidly and suddenly, require extraordinary amounts of continuous electricity concentrated into one geographic region almost overnight. Which means utility providers now face an increasingly difficult question. How do you supply enough electricity for the AI boom without destabilizing existing infrastructure systems already under strain? And solving that problem is not simple, because expanding electrical infrastructure takes enormous time. New substations must be built, transmission corridors expanded, transformers manufactured, power generation increased, permits approved, industrial construction completed. Entire sections of regional electrical infrastructure often require upgrades before new AI facilities can even become operational. And meanwhile, AI demand continues accelerating faster than many utility providers originally anticipated. Which is why technology companies are now aggressively searching for regions with cheap electricity, stable grids, large land availability, cooler climates, and expandable infrastructure capacity. That search is beginning to reshape geography itself. Texas, Arizona, Virginia, Ohio, the Pacific Northwest. These regions are increasingly becoming strategic AI infrastructure zones, partly because they possess the electrical capacity capable of supporting hyperscale computational growth, and entire local economies are beginning reorganizing around these projects. Construction activity increases. Industrial contractors become busier. Substations multiply. Transmission corridors expand outward. Utility infrastructure scales upward. Industrial land values rise, because supporting artificial intelligence at this scale requires far more than software engineers. It requires enormous physical industrial systems expanding continuously beneath the surface of modern civilization. And in some regions, competition for electricity is becoming increasingly intense. Because AI companies are not the only industries demanding more power. Electric vehicles require charging infrastructure. Manufacturing continues expanding. Population growth increases residential demand. Air conditioning systems consume more electricity during increasingly hot summers. Industrial electrification rises across multiple sectors simultaneously, and now AI arrives on top of all of it. Which means electricity demand across some regions is beginning to surge from multiple directions at once. And that creates long-term questions about the future stability of modern power systems themselves. Because electricity generation is now becoming part of the AI race. Some technology companies are exploring partnerships with nuclear energy providers. Others are investing heavily into renewable energy infrastructure specifically to offset future AI consumption. Some are even constructing dedicated energy infrastructure directly near hyperscale data center campuses themselves. Because reliable electricity is no longer simply a utility issue for technology companies. It is becoming a strategic necessity. Without enough electricity, future AI expansion slows down, which means energy infrastructure may increasingly determine which regions dominate the next phase of technological development. And that reality fundamentally changes how we should think about artificial intelligence itself, because most people still imagine AI as something abstract, something virtual, something existing invisibly somewhere inside the cloud. But the cloud is physical. Artificial intelligence is physical. Every AI interaction depends on power plants, substations, transmission systems, cooling infrastructure, industrial facilities, water systems, fiber networks, and giant electrical grids operating continuously behind the scenes. The modern AI economy is increasingly being built on top of enormous industrial systems consuming real-world resources at staggering scale. And those systems are continuing to grow rapidly. At night, across giant industrial campuses, thousands upon thousands of processors continue operating endlessly, while cooling systems circulate air through massive server halls filled with blinking lights and metallic infrastructure stretching into the distance. Outside, transformers hum beneath floodlights, while transmission systems carry huge amounts of electricity across long distances to keep these facilities operational every second of every day. Most people will never see these places. Most people will never think about them. but increasingly, modern civilization depends on them. Because AI is no longer simply changing software, it is changing infrastructure, changing electrical demand, changing utility planning, changing industrial development, changing the physical systems underneath modern civilization itself. And as artificial intelligence becomes more advanced, the hidden electrical infrastructure supporting it may become one of the most important industrial systems of the modern era. Because behind every chatbot response, every generated image, every recommendation algorithm, and every automated AI system is something far older and far more physical than most people realize. Electricity, and artificial intelligence is beginning to consume it at the scale of entire cities. As AI continues expanding across the modern world, the infrastructure supporting it may quietly become one of the defining industrial systems of the 21st century. Most people will never see these facilities, but increasingly, modern civilization depends on them. This is civilization underneath. New documentaries weekly.